Good morning, everyone. If you can hear me, I'd appreciate if you could indicate so in the chat line, just so I know it's going through. Thanks, Austin. And Sean and Dayton, so on. That's great. I have a 2-hour session set up for this morning here. And we'll be dealing primarily with problems, what I refer to as end of chapter problems for chapter 2. We'll get to that very shortly. I will indicate the session is being recorded, just so you're aware of that. And in chapter 2, there are 4 videos in Learn covering this chapter. They're in sequence. What I will do is work problems and refer to that material as we go through it. So what you should have handy right now would be your textbook, because the problems will come from the end of chapter. Some of the problems will also come from what's referred to in Learn as the supplementary problems. Might even say supplementary problems to solve, I'm not sure. But you'll also need access to that as well as we go through this material. In chapter 2, we're going to be dealing with the notation of interest and interest rates. And within that context, we'll be dealing with what's referred to as compound and simple interest. Note the different denotation of that. Interest is usually, or interest is notated by a capital letter I, and interest rate is notated by a lowercase letter I. Just be aware of that. And once we've sort of touched that with a question or two, we'll deal with the distinction between effective and nominal interest rates. That will be very, very important in a sense that it will, a good understanding of that context of effective and nominal interest will carry through to later chapters, chapters 3, chapters 4, chapters 5, and potentially chapter 7. So do try to get your head around that when we get there. We'll work a few problems to show you the difference between the two. We'll take a brief look at what's referred to as continuous interest. And then we'll turn our attention to cash flow diagrams. Many of the problems that you encounter on the exam will require that a proper, correct, fairly neat diagram of a cash flow diagram be provided. It'll be worth 1 mark within the question. And then we'll turn our attention to depreciation. Although the book does reference 7 or 8 or 9 different methods of depreciating the value of an asset, this book and in this course, we will only deal with 2 of them. One is referred to as straight line depreciation. The other is referred to as declining balance depreciation. Once again, a pretty fair understanding of that is important in that it does surface in the following chapters as to the depreciation of an asset, most particular chapter 7, but it is covered in chapter 2 in terms of an introduction to the concept of the depreciation of an asset. So I'll bring that to your attention as well. I will be using a document camera here very shortly, and we're going to start working problems. But like I mentioned, you should have your textbook out. And if you're in chapter 2, you should go to page, where do we begin here? It looks like page 44. That is where we will be, where you will see what's referred to as end of chapter problems. And we will do a number of them. Some of them are pretty short, some of them are pretty basic, but don't take them for granted. And then on conclusion of our work today, we will be setting up next week to either conclude this chapter, and if we're, when we do conclude it next week, if we haven't done so this week, either way, we will be dealing with chapter 3. I have to be a little careful, I think, when I say next week there, because next week is the academic break. It's a study week. It's a reading week, whatever you want to call it. So you will have to perhaps use that time on your course material, not mine alone, of course, all courses. That's the general idea. And I also sent out an email to everyone. I hope I caught everyone in that email. I use the Learn class list is what I use when I send those sorts of emails out. So everybody gets a copy of that email on a standalone basis. So although you got a copy, all of your classmates should have got a copy of it as well. And it made an announcement that on 2 weeks today, as a matter of fact, quiz 1 will be presented to you. It'll be in Learn using the Learn quiz tool. 15 questions. I believe they're all multiple choice, and it'll begin at 1 o'clock on that day. Later in the day, I will do my best to set up an opportunity for you to review the material, to review the quiz, so that you can take a further look at it as to the questions you got correct and the questions that you did not get correct. It'll also show the correct answer for those that were right or wrong. Clearly, if you got them right, it'll be the same. It'll be the same answer. So I'll leave that with you. And what I'd like to do now is turn our attention to end of chapter problem 2.3 in the textbook. So if you could take a look at that, I'll give you a second to read it. Well, perhaps I make another comment or two, or maybe even better than that, I will attempt to bring up my document camera on a share here. So I'll do that hopefully right now. And you should now see that occurring. If you cannot see a graph paper with my pen kind of waggling around on it, please indicate so in the chat line. If by chance you can see it, and that's the hope, then I'll just assume that that's the case, simply because I want to just simply know if you cannot see it. But I see a couple people have indicated that going to interpret that to mean that you are now seeing that graph paper. So I will work in this class, and I say this only the first time around because it'll become the standard pattern that I use. I will work many problems at end of chapter. It's presumed that you've already looked at the videos related to the chapter by the time we get to this point in the of the week of the course. You've looked at it, and I'm going to work problems. And as I go through the problems, I'll show you a number of things, not just simply the solution and the answer. I'll show you, not on all of them or most of them, but on some of them, I will show you how I will grade that question. So you are somewhat, so that you are fully aware of the pattern I use for grading questions. There is a rubric posted in Learn. I believe it's probably near the bottom of the content. I can't quite remember. And I don't have my Learn up on my screens here, but that's where it probably is. And if you could take a look at that at your convenience. There's no need to look at it today, but you should. Later, when we get into chapter 3, though, I will go through it in greater detail, because by then we will have more information that's relevant to the marking guidelines. I could call it that. Some people might call it a rubric. So that'll give you that insight. Try to keep my eye on the chat line as to any incoming questions. I will be often working on this paper here. So my chat line is off to my right on my computer screen. So I may not see all of your incoming chat comments, questions. But if I'm not getting it, please indicate, cut in on the audio line and give me the question that way. If I do pick it up, I'll try to respond to it as we go through the work. So our first one today will be, and I usually start these out. Let me just set this camera up just slightly better so you can see the top of the page. I'll focus it a little better. Hopefully that's clear. So this will be end of chapter problem 2.3 is the first one I want to look at. And when you read that question in the textbook, it simply indicates what principal amount will yield. No, down the wrong one. I'm just mixed up on the reading of these. 2.3 says how much will be in the bank account at the end of 5 years if $2,000 is invested today at 12% interest per annum, compounded yearly. That's a straightforward solution to this. And we will take a look at it here at 2.3. You should be recalling from your material in the textbook, and in this chapter I won't use cash flow diagrams because the concept on these problems have not been introduced just yet. We will get to hopefully 1 or 2 questions later in the end of chapter problems that demonstrate how you can, at least in the initial stages, start to develop the cash flow diagram, which becomes somewhat important when you're doing questions. It allows you to extract out the meat of the material, if you will, get rid of a lot of the fluff that's in there. In other words, you're laying it out and just simply putting into that cash flow diagram the critical data that are necessary to solve the problem. And it doesn't matter what it is you're purchasing, whether it's a hammer or a front end loader, doesn't matter. It doesn't matter if it's Peter, Paul, or Mary who is buying something or perhaps saving money. Those things really don't matter towards the solution once we get that far. But the questions are often worded in that context. Excuse me. So in this case, under 2.3, the solution to that would lie in this formula here. And we now have to start thinking of things as to, are we dealing with the present or are we dealing with the future? And in this case, it's indicating here how much money will be in the bank account. Well, that's telling us down the road how much. That's a future amount we're looking for here. So the formula for doing that would be the future value, or the future, we can call it a value for now, the future amount, if you like, will be equal to the present amount multiplied by 1 plus I to the power of n. Again, this may be stuff you're somewhat familiar with from other schooling that you've done, or it may be new to you. So I'm going to assume that we're dealing with much of this material for most, if not all of you, that this is your first exposure to it as we work our way through it. For those of you who understand it, the first part of chapter 2, not the whole of chapter 2, but the first part of chapter 2 may seem a little Mickey Mouse to you, but I'm going to start that way. So we're looking for a future value. And how much is it? Well, what we know is that the present value, because in this case, one is starting out with $2,000 that's invested today. Today means the present value. Today is now. It's time 0. So we're starting out with $2,000 here. We're going to multiply that by 1 plus I. I is the interest rate. Again, I'll mention here is that if a capital I would be the interest amount. So be careful with that. And the interest rate here is 12% per annum. So 12%, and we will work that as 0.12. a decimal portion of 12% or a decimal representation of 12%. And the number of N is the number of compounding periods. Well, interest is compounded every year. It says there 12% interest per year. Compounded yearly. It happens every year. The interest you earned every year is going to be added to the amount you had at the beginning of that year. So at the end of that first year, you have more money. And you could repeat that for each compounding interest period. How many compound interest periods are there? Well, in this case, there's 5 of them because we want to know how much money will be there at the end of 5 years.
Hey, Wayne.
Yeah?
What do the variables stand for, like the F and the P?
Okay, well, the F would stand for the future value, and the P will stand for the present value.
Oh, okay, thanks.
No problem. You might, at this stage, you might refer to it as a present amount and a future amount. Some people might even call P the principal. That's what you have today, the principal amount, what you're starting out with. We will eventually redirect our definition of those terms into what's referred to as a future worth or a future value and a present worth or a present value, and we'll introduce an annual value along the way. But that's chapter 3 stuff, and we won't worry about that right now. So if we do the arithmetic on this, you would end up with an answer here of $3,524.68. Now, often in the back of the book, when you're looking these answers up, some of them are answered. Not all are, maybe less than half. But in Learn, I've provided the answers to all relevant questions. Sometimes I'll write in there omit because it goes beyond, that type of question goes beyond the scope of our study. And I don't put those answers in there. Or I may have just simply said omit, something like that. So just so you're aware of that. There will be a few mistakes made at the end of book chapter. Try that again, end of chapter answers, which is in appendix, and I forget what it is. Let me just quickly reference it as our first time through here. Looks to me like it's appendix B in the textbook. B is in Billy. And you should be able to get them now. Now, on occasion, I'll be kind to the authors and say there was a typo. The reality is there's too many of them to be typos. So if I've discovered an error in any of the questions, the correct answers to the best of my ability are on Learn. I have developed the correct answer myself and put it into Learn. Also at the end of textbook or appendix B, often the answers are rounded off. So in this case, it may well be. So that would be approximately equal to $3,525, and that may be the answer at the end of the book. You will not lose a mark because of a few pennies one way or the other. That's what I'm after. I'm more interested in the methodology you're using and the correct utilization of the data in those questions. And if you were given a question, you probably might not get a question quite this easy. But if you were given this question, you would get 1 mark here. I'm going to use a different color here. 1 mark for giving me the formula. 1 mark for correctly placing the values into that formula. And then 1 mark for your final answer. Now that will come from the rubric that I have put into Learn, and I will do that sort of layout there every once in a while just to kind of keep you posted on how I will mark a question. So something like that would be worth 3 marks. Now, the question doesn't ask for a cash flow diagram. It could, and if it did, you would get 1 more mark. Check up here somewhere. In another situation, this one doesn't, I might ask for a concluding or a decision statement at the end. And if it did, you'd get a mark for doing that correctly, as long as it contains the correct information, of course. So that gives you a rough idea of how I will mark questions. I will go over that a number of times as we do this because it's very important that you understand it and have a good appreciation for it. It is laid out in that rubric, and when we go into more complex problems, I will go through that rubric with you online during one of our sessions here, probably towards the end of chapter 3. In the middle of it at the very earliest, maybe towards the end of it. And it'll again let you understand how you accumulate marks in a question. The reason I do it this way is that if you make a mistake and if you just give me an answer, and if it's wrong, you get nothing. If you maybe made a mistake here and called it 3,672, something went wrong with you or your calculator, then you get nothing for that question if that's all you're giving me. But if you gave me this and simply screwed up on the arithmetic, you would still get 2 out of the 3 marks for that question. Okay, so that'll give you some idea of why I like to see it that way. The other reason that I like to lay it out this way and see it all laid out nice and fair, relatively neat. I know in assessment situations, you know, things get kind of scribbled up pretty quick simply because you have a timeline that you're dealing with. But the other reason I use this is to enforce the idea that in many cases in your future, you may be putting together a report for a client. Client might be your boss, might be the boss of your boss, or it might be an external client to the organization as a part of a report. And in that context, it's all like, in all likelihood, you'll be required to lay it out, not just simply write down a number, circle it, put a star beside it, and say, Eureka, here it is, type of thing. So again, I will emphasize that I like things laid out using, if you will, the base formula you're working from. I'll refer to that often as the prime formula. The correct values in that formula, and then your concluding answer. Now, if you take 1 or 5 steps to go from here to there, that doesn't matter to me. Some people can do more in their head and in their calculators than others can. That's fine, no problem. Just do it that way. That's your comfort zone. But this is what I'm looking for. This, and this when I mark a question of this nature. I'll now qualify that by saying this is a relatively simple scenario, but nevertheless, that's what we have. So let's take a look at the next one. And the next one that I'd like to look at would be 2.1. So if by any chance, as I'm working, and I'm not always looking at the screen on my computer when I'm working, sometimes I end up working like down at the bottom of the page. In other words, I've come down here and done work, and I'm down here and I'm still going full speed ahead. You can't see what I'm doing. So please cut in with the audio line and just ask me to raise my paper up or lower my camera downwards so that I'm picking it up. I don't want to be working if you can't see it. So question 2.1 is about if a sum of $3,000 is borrowed for 6 months at 9% simple interest. Remember, I mentioned earlier, we're going to be dealing with compound and simple interest. There's a distinction here as to how we handle that. So be aware of it. What is the total amount due? That would be the principal and the interest at the end of 6 months. So what we have here in this question is we're dealing with simple interest. Now we can start this question out here by saying that the future amount, again, we're looking into the future. I want to pick up the wording in here. What is the total amount due at the end of 6 months? At the end of 6 months is not today. Today is the present. At the end of 6 months is the future. So we're looking for a future value, F. And it will be equal to the principal plus the interest amount for simple interest. But we know that the simple interest amount is equal to the principal multiplied by the interest rate by the number of compounding periods. So we could substitute that into this formula here, if you will, and I'll rewrite it here. F would be equal to the present amount plus the present amount multiplied by the interest rate by the number of compounding periods. Don't really need a bracket there. So I could do some algebra on that, but it's not necessary. I could do algebra by pulling out the p's and putting brackets around the balance and that sort of thing. It's not really necessary. And again, this is at your discretion as to how you might handle a problem of this nature. But we know that the principal amount here is $3,000 plus the principal amount again multiplied by the interest rate. Well, the interest rate from the question was 9%. 0.09, work in decimals. Some people will put it in this case is 9 over 100, and I guess there's no problem with that. I understand what you're doing, and if that's your way of presenting the material, that's not a problem to me, and you can do that. But normally, just represent your interest rate as a decimal, or like I said, you could put 9 over 100, which is essentially the same thing. And the number of compounding periods. Well, the simple interest here is per year, 9% simple interest per year. And yet we only want to know how much will be there at the end of 6 months. So we need compatibility. If I were to give you a scenario whereby you are asked to multiply two things together, and let me use a simplistic example. If I were to ask you to multiply and determine the area of a rectangle, which is 30 feet long and 5 meters wide, could you just simply multiply 30 by 5 and have the answer? And to me, you should be saying, no, you can't do that because they're in different units. We'll have to compute the feet to meters or the meters to feet so that we have the same units. Same thing here. The interest rate is per year, but our compounding period, or our number of periods in this case, is 6 months. Well, 6 months is a half a year. We need years here as well. So it would be 0.5 in that case. So if we do that arithmetic, you should get an answer of $3,125. Some of you will probably just be writing this down. Others will be working it as we go along. My recommendation is that you work it as we go along to make sure you have a full understanding. And if by chance you are working the problems as we go along rather than just writing down what I'm writing, if you get a different answer, please let me know. We're all human and mistakes are made. And if I make a mistake, I need to know about it. It happens. So bring it to my attention. I'd rather you did that. And I can only apologize for that if it occurs, and it probably will. I can only apologize, but I don't want to leave a page like this up that you're taking down with a wrong material, wrong input, or wrong output on it.
I believe the answer is 3,135, not 25.
Okay, let me just see that. And you're correct. So I'm going to change that. And I appreciate that. That was not a test to see if someone was actually checking it. I am a bit, I'll be straight up with you, I'm a bit dyslexic. So sometimes my numbers get a little mixed up. But having said that, thank you for that. And I do appreciate that. Okay. So that'll take care of that one. So let's try one more now, and we'll take a look at 2.2. So end of chapter 2.2. What principal amount will yield $150 in interest at the end of 3 months when the interest rate is 1% simple interest per month? Okay, well, we can start that out here, and we could use this formula here for that one. All of these formulas are in the textbook, and they are referenced in the videos that I've earlier referenced, or sometimes they perhaps are more correctly called the asynchronous lectures that take place. So they're all shown in there. My asynchronous lectures, hopefully you already know this, but they are a number of slides containing information and my voiceover with respect to each slide in turn to speak to the theory that's in the textbook as well as to anything that may be on the slide. The slide does not contain everything that's in the textbook. It's just a guideline to step our way through it. So ultimately, your study should devolve back to the textbook and not just simply my asynchronous lectures and the synchronous lectures that we're now doing. You should always go back to the textbook for your material. Okay, so if we're doing a problem of this nature, and it says what would be, we said 100 will yield. So that's what we're going to get somewhere in the future. But we also know that using this formula up here, we know here that the interest amount will be equal to the principal times the interest rate times the number of times that the interest rate is applied. In other words, the number of periods involved. But we want to solve for what in this case? It says, what is the principal amount? We want to solve for P. So P, we may have to do a little bit of algebra here, and although this is pretty basic algebra, I'd have to admit, the algebra will get a little more challenging as time goes on here. So we have P is going to be equal to the interest amount for simple. S stands for simple.
Can you move your paper up?
And thank you. Yeah. Also, and I do appreciate those comments because I lose track by not watching the screen, but rather where I'm working. If it's also a little blurry, let me know because I can focus it. Sometimes it gets out of focus on me a little bit here. There's a quick auto focus on it that I can do if you find that would, if you think that's a problem. So it would be the principal amount, the simple interest amount divided by I and N. Could put a point in there, I guess. So if we do that, the interest amount from the question was 150. That's how much interest was earned at the end of 3 months. The interest amount, well, it was 0.01 per month. And how many months were involved? 3. Again, before I do that arithmetic, again, to multiply these together, we need to have them both in the same units, month. This is 1%, if you will, per month. This is 3 months. So we have to be careful that we are always aligning our units of arithmetic. So if we do that, you should end up with $5,000. So that would explain that one there for us. And again, basically, each of these questions would probably be worth 3 marks each if you were given those. You won't get a question like that on the final, but the midterm will be addressing chapters 1, 2, and 3. And so, yeah, you could end up with some simple questions of this nature for the midterm, but not for the final. We'll be involved with much more challenging questions by the time we get that far along in the course. Okay. What I'm going to do now is, just so that we cover the the spectrum of our questions, I'm going to take a look at problem 2A. Now, problem 2A is a supplementary problem. It's a problem that's posted in Learn under the content of supplementary problems. And there's problems in there for chapters 2, 3, 4, and 7 is what I have in there. These are not in the textbook, but they cover the material. And I've acquired them and put them in here, developed them and put them in here in order to provide further insight into the content of the chapter. So in there, this here, we'll call this here, it's not an end of chapter, I'm just going to call it 2A. I'll up that here in a minute. There we go. So 2A, this is a supplementary problem. I guess you could write that out here. Supplementary problem 2A. So if you want to take the moment here to pull those problems up, that would be good, or at least at one page. I can't remember if they're listed separately per chapter, and they may well be. The answers are also in that same module in Learn as a separate document, I believe. And so you have access to that if you like. So this particular problem here, and I'll show you what it looks like maybe, because not all of you may have had it up here. But problem 2A, it says a bank loans money to an engineering company at the following nominal interest rates. Now, nominal is the amount of money that institutes will often quote as their interest rate. You will find, because it is nominal, that we don't work, with one exception, with nominal interest rates, nor does the bank or the credit union or anybody loaning you money that gives you a nominal rate. The effective interest rate is what you would need, or the sub-period interest rate is what you would need to solve the problem. And a favorite's not the best word there, but a frequent question that I get along the way as we get into the material, especially in the next chapter, but nevertheless, it's applicable here. This is an introduction to it. When do I know whether to use the sub-period interest rate or the effective interest rate? Because when correctly used, both will give you the answer correctly. However, when you look at the problem you're dealing with, what you want to do is have compatibility of your data. Compatibility is going back to that scenario I ran a few minutes ago there, where everything is in feet or everything is in meters. Same idea here. So if you are finding that in the question things are being measured at a say a monthly level, and if your interest rate is being given to you at, say, 12% compounded monthly, you would want to calculate the sub-period interest rate because you want it at the monthly level. So again, that may feel a little strange to you right now, and if it doesn't, that's good for you. But for the most time, until you do a few of these problems, it's a little more challenging to kind of get your head around this situation. So what I'm going to do here is work our way through this one here as a bit of a further insight. So problem 2A says a bank loans money to an engineering company at a following nominal interest rates. These are nominal. And with one exception, which I'll point out here soon, with one exception, we do not work, nor does anyone else work, with nominal interest rates. In each case, what is the sub-period interest rate? So that's what we have to solve here. What is the sub-period interest rate? So if we take a look at problem 2A, the formula we're going to use for this that you've acquired, I'm just going to put this up here where I can see it. The sub-period interest rate will be I, that's an interest rate, that's what we're dealing with, little I or lowercase I, with a small s beside it. Now that in this case stands for a sub-period. If it were effective, it would have a little e there. I subscript s is a sub-period interest rate. I subscript e is an effective interest rate. This problem is dealing with what is the sub-period interest rate for all of those questions mentioned. So we started out with 12%. So the basic formula here will be the nominal interest rate divided by the number of compounding periods. That's a pretty simple formula, easy to memorize. All formulas that I use are in the textbook on the back cover. And I've also provided a copy of that back cover, if you will, in Learn, so you can print it off and have it with you at all times. Highly recommended when it comes quiz and or exam time. So the sub-period interest rate is equal to the nominal interest rate, which is what we've been given in this question. Recall the question here. Company at the following nominal interest rates, in each case, what is the sub-period interest rate? So pretty direct. So in this case, because we're simply dividing, we can work it with percentages if you're inclined that way. So what we would have here would be 12% divided by M. M is the number of compounding periods. And this is compounded monthly. So how many monthlies are there in a year? And you should be telling me there are 12 months in a year. Therefore, the sub-period interest rate is 1% per month. Or 1% monthly, if you like. Okay, so that's pretty straightforward. So we're going to do that a few times so you get familiar with this. The next one here, same situation, 12%, but it's compounded quarterly. So again, when you're doing my work, when you're following my lead and you're doing things for an exam, I need to see the initial formula. Call it the prime formula, if you like, if you will. So once again, so I'll label this part A here just to distinguish these. B will be I subscript S for sub-period interest rate. It's equal to R over M equal to 12%. That's not changed. But the number of compounding periods have changed. It's compounded quarterly. How many quarters are there in a year? Well, that would be 4. 4 quarters in the year. That would mean here then that it is the sub-period interest rate would be 3% quarterly. Try C. It is, same question, 12% has not changed, but it's compounded semi-annually. So semi-annually, once again, the formula, IS nominal rate over the number of compounding periods is going to be equal to 12% divided by the number of compounding periods per year. Well, it's semi-annual, twice a year, every 6 months, same thing. So it'll be 6%. Semi-annually. You see the pattern now that's developing here. So let's look at D. D on this is 12% compounded annually. So once again, the prime formula or the start off formula, I subscript S is equal to R over M. R is the nominal rate, 12%. The number of compounding periods per year, it's compounded annually. So there's only one in the year. So it will be 12% annually. So that gives us that insight now into the use, or at least the calculation, to determine a sub-period interest rate. We'll do the effective interest rate soon, not right now. But the question goes on here, and I'll ask you to think about this one. The next one for E says the monthly rate of 12%. What is the sub-period interest rate? Just think about that for a minute. What would be your answers? Anybody want to give me an answer on the chat line? I have 1, 12, when you send me information privately, no one else sees it. That's fine if that's how you want to do it. But I just thought I'd let you know that. Well, the answer to this is 12. It's already a sub-period interest rate, so we can't make it into it again. So the answer to E would be the monthly rate of 12%. So it's 12% monthly. It's already given to you. So be sure when you're reading a question, you're determining whether or not it is compounded, or are they giving you the sub-period interest rate to begin with. In this case, they're giving it to you. So the answer here is 12% monthly. And F, how about an answer for that one in the chat line? No, to answer your question, Austin, no. The sub-period interest rate can be any of those that we worked out. It could be monthly, could be weekly, it could be daily, hourly. I'm not sure of the grammar here, but secondly, it could be semi-annual, every 6 months. It could be quarterly, which we've worked. Could be annual, which would be which we've also worked. So you have to read that little phrase carefully. Yeah, you did. I'm sorry. I try not to use a person's name. I apologize, Austin. I've outed you. I try not to use a person's name when they send me a private note, but I apologize for that. The answer for S, and it's coming up now on my screen, And okay, love a class with humor. F would be 6% semi-annually. And again, it was given to us to begin with. So the operative word here is when you see an interest rate with the phrase compounded, that's a tip-off. You have a nominal interest rate to begin with. Now, it may be if it's compounded annually, you're going to come back to the same number as we did when we did item, where am I here? Item D. You can still go through the arithmetic, but if it's compounded annually and you're looking for a subperiod of annually, you have it already to begin with. You can always put 12 down and divide it by 1 and get 12, but there'd be no need to do that. Okay. So that takes care of problem 2A. Let's go back and try a few more now. The next one I had on my list, I have to find it here, was 2.4. So we'll try that one here. Now you have to be careful with this question here. If you're in the textbook now, and make a correction to it, okay? What they're saying there is that how much is accumulated in each savings plans, in each of these savings plans over 2 years. So there's an A and a B part to this. What they have stated in here is that symbol before the dollar or before the numbers is the euro symbol. So 1,000 euros today at 10% compounded annually. And unfortunately, if you work it that way, you won't get the correct answer at the end of the textbook. 1,000 euros should read $21,000. So you want to make that correction in your textbook. And for part B, 900 euros should be 2,900 euros. Now the correct answers to these are in Learn under what I've placed up there as answers to EOC problems. This was detected in my first year of teaching this course, and I've made the correction there, but it's hard to make the correction in the textbook for everybody, of course. I can only do it in my own. So you might keep that in mind. Once again, I'll repeat it. 1,000 euros should read $21,000, and 600 euros should read $2,900. So let's take a look at this. EOC 2.4. And we'll do part A here. Now, what we are all, yeah, go.
Will we be stopping for a break at all?
No, I tend not to. I just go for 2 hours and work my way through it. Clearly, if someone needs to take a break on their own, they can do that. But
Okay.
I tend to work straight through. It's my culture, I guess. But yeah, no, I don't stop at the hour for 10 minutes. I just work it right through. 2.4, how much is accumulated at the end of 2 years? So we have a 10% compounded annually. So at the end of 2 years. So to answer this, and we'll go process, you will learn that you may not need to do the first part on occasion here, but we could determine the sub-period interest rate here because it is given here as a it is a compounded annually. Compounded tells us it's nominal. It's a nominal rate. But because it's annual, it'll be the answer will be the same, but we'll just go through the arithmetic of it here. So the interest rate, I'll write that down here, is equal to 10% compounded. And that's the operative word. Keep watching for that word, annually. So we're going to say here then that the sub-period interest rate will be R over M, will be 10% over annually. Well, annually, that occurs once a year. So we're back to 10% is our sub-period interest rate. And we can use that. But and I should write this in here, yearly or annually, either way, semantics, and it's synonymous. So our formula here, back to where we actually began today, is going to be the future value is going to be equal to the present value multiplied by 1 plus I, it'll be IS in our case, to the number of compounding periods. So that will be equal to E is 1,000, 1 plus I is our sub-period interest rate, which is 10%, 0.10, don't really need the last zero, to the power of n. Because this is yearly, we want to know how many, and it's compounded yearly, and there's 2 years, this value up here will be 2 compounding periods. So what that really means is that after 1 year, you will have accumulated interest on the 21,000. That interest will be added to the 21,000, and that becomes your new value. And again, more interest. So you're earning in compounded interest is earning interest for you as you go along the timeline. And the more frequently in the year in which it is compounded, the more frequently the interest accumulated over that period, be it a month, a week, a day, or a year, or half a year, the more you do that, the more it will be added to the previous amount. So it will accumulate a little quicker. So if we do the arithmetic on this, you should end up with $25,410. So after 2 years at 10%, 21,000 even becomes $25,410. So you have a gain there of $4,410, but we're not asked for that. Part B of this is a little different in that once again, let's take a look at our, it is compounded monthly. So our I'll start that out here, our nominal, our interest rate that we're given, but it's nominal, is, I just have to find it here in the question, 12% compounded monthly, 12%. Compounded monthly. So we need to determine what is the sub-period interest rate. So we know that the sub-period interest rate here is going to be, as notated here, R over M. R is the nominal amount, 12%. Compounded monthly. Well, there's 12 months in the year. So every month it's going to be compounded and added back to the beginning of that period every month. So it's going to be 12. So the actual interest rate is going to be 1% per month or monthly. So that's a little different than what we had before. We're going to work with a sub-period, but we're working at the month level for the interest rate. So our formula, just like before, will be F, the future value, will be equal to the present value onto 1 plus I N. So the principal amount here was $2,900 onto 1 plus the interest rate of 0.01 in decimals, of course. And N has to be the number of compounding periods. Well, they're doing this for 2 years, correct? Let me find it here. At the, say, over 2 years. So what will N be? Can you tell me? $24. We need months up here. We can't leave it as years because our interest rate is in months. So the number of compounding periods has to be in months. So putting a 2 in there will undoubtedly get you a wrong answer. If you do this, you should end up as an answer here of $3,682.23. Okay, now, again, I'll just back up on this question 2.4 to quickly reflect on marking here. So on a question of A, and it'll be the same for B, although A may not be that relevant here, I probably might not award a mark for the because it doesn't really change. But here you get 1 mark, 2 marks, 3 marks. Now in the case here, we actually had to compute and not just surmise the sub-period interest rate. You get 1 mark for this, 1 for the prime formula, 1 for correctly putting the numbers into the prime formula, and then 1 for your bottom line result. So part B, I would probably award 4 marks for this type of question here. Up here, I'll be straight up with you. I might or might not include this. So maybe, maybe not. But that's how I would mark that one. Just so again, I'm going to try to bring that marking scheme in front of you frequently, not on every question, but certainly in the beginning on a fair number of questions so that you're aware where the marks begin, how you accumulate them. As I said, it's the way you should put it into a report if you're doing a report for a client. And in many ways, you are, because I am your client. In putting an exam together, you are answering that for me. And as a result, you should lay it out fully, whether that's your boss in an organization, but it clearly indicates what you're doing to get to the end result. Now, we could have also solved this by using IE, but we haven't learned yet how to calculate the effective interest rate. Okay. Let's try 2.5. Now, as we get into the other chapters, just to deviate here for a minute, take a little sidetrack, but if you're working these problems on your own, which you should be doing as we do each chapter, and if you recall from my asymmetric lectures, in those lectures, I ask you to pause the video from time to time to examine a worked out problem within the context chapter. And then I also ask you to pause the video to work out some end of chapter problems that I've listed. Ordinarily, those would be the problems I would be doing on the whiteboard in class. We're not there, so this is the best way I can approach it. If you are encountering one that you can't solve and would like me to do it in the next class, send me an email. First come, first serve, and I will list them as they come in. Sometimes I get none, sometimes I get one, sometimes I get 8 or 9. But if you're struggling on one, you can send me the question number. Just simply, could you do EOC 3.8 in the next class? And if I'll take them on a first come, first serve basis and put them out there. Sometimes more than one person will send in a request for me to do that one problem. I've had as many as 3 or 4 people ask me to do one particular problem versus another. And that becomes a little more likely as we get into chapter 3 work and then even chapter 4, 5, and 7 work. So,
Hey, Wayne.
Yeah.
So those videos you post, is that meant to be looked at before the class, or does it matter?
Some people look at them after, but you should look at them before. That's the intent. Yeah. Okay. Probably in the early chapter, you don't lose much by doing it in reverse, but it gives you that insight, and it also tells you which problems you should work in preparation, like to get an understanding of the chapter. And then if you're stumped, then send me that, and I'll do it in the next class. Also, alternatively, I can't promise a return on all of these because I can get overloaded here quite easily. But if you send me your work for a particular question, I will scan it and indicate where you may have gone wrong. And sometimes I'll meet with you in my private WebEx room, and we'll go over it together if I feel that that's perhaps a better way of handling it, rather than me trying to explain the difficulties you encountered in an email. Sometimes it's straightforward, and I can do it in an email. So again, it's another opportunity to have a better understanding of this, if you will. If you would like to send me your work, presumably the ones you're having troubles with, not the ones you got right, and I'll take a look at them and try to point out, the shortfall in your working. I normally will not respond to much in the way of someone saying, could you send me your work for question 2.17, for example. I normally won't do that. If you're having trouble with it, send me your work for 2.17. I'll look at it. And as I mentioned, I can maybe respond by email to clear it up, or I may say, let's talk about this on WebEx personal room when you have time. We'll set it up that way. Usually, and that includes into the evening for me. I tend to work, or I'm available within reason. Most nights I'm probably available up to 10 or 11, sometimes even later, to help out in this way. I'm not necessarily sitting at my computer, but I will get an email on my smartphone saying that somebody is waiting for me in the WebEx room, and I'll go there, or I'll see the problem and I'll come to my computer and I'll take a look at it and send you back an email, or I'll say, let's meet in the WebEx personal room to further discuss, something like that. So that will hopefully aid in your studies as well along the way. I just wanted to look at the chat line here. No, the nominal interest rate I'm just looking at these chats here. Maybe I should see here who sent that in before I out somebody else. Yeah. No, the nominal interest rate had to be expressed annually. That's not the case. The nominal interest rate will be a number, a certain percentage, compounded so many times in a year. So it's perhaps better wording than what you're suggesting there. If it says compounded, it is unquestionably nominal. So anything that says compounded weekly, monthly, hourly, semi-annual, quarterly, even yearly. But when it's compounded yearly, you go full circle back to the number you're working with. So there's no need to work that out unless you want to do it for practice. You're welcome. I didn't check before that one came in. Let me just back up here a little bit. Yep, I think I've seen those. And again, when you do a few of these questions, it'll become clear. I'll be the first to admit it's a bit, what's the word I could use here? It's a bit challenging first time through this material, but it'll become for almost all of you, if not all of you, the concept of a nominal interest rate, and I need to convert over to a sub-period interest rate or an effective interest rate. We have yet to deal with that one. It's in the material, but we have yet to do any problems on that. So let's take a look. That one there that I just did, I gotta check my notes here. That one there was 2.4. So let's take a look at the next one that I label. Let's take a look at 2.5. Okay, I've got that down here already. 2.5. Greg wants to have $5,000 in $50,000 in 5 years. I tend to use, just as a matter of interest here, I tend to use commas and not spaces in separating my digits out, just so you know, doesn't matter to me. The bank is offering 5-year investment certificates that pay 4% nominal interest. Now, in this case, they're even telling you it's nominal. That normally doesn't happen, but that's the question. That's fair. But I would know it's nominal anyway because it's compounded quarterly. How much money should be invested in the certificate to reach his goal? So in this case, you know what the future value is. What you don't know is what is the present value that will get me to that future value. So we have to reverse this process. Up to now, we've been looking for future values. Now we're looking for a present value. So let's take a look at 2.5. Some people like to, in their questions, write out, if you will, the information that you've been given. Normally, that will show up on a cash flow diagram. But we're not dealing with cash flow diagrams just yet. So you can always do something like that. Some people do it anyway, even with a cash flow diagram. They kind of like to say, well, N here is equal to 5 years. F is the future value. It's equal to 50,000 years, $50,000. I is equal to 4% compounded quarterly. Now, how can we work this? I'm going to work it in two ways because this question now will introduce us to the concept of both an effective interest rate and a sub-period interest rate. So let's do it by the effective interest rate to begin with. We have yet to do that. The formula for the effective interest rate, and one could, I guess, for simplicity here, put down here, P is the unknown. I normally don't write that down. It's in the question. and it'll show up in the answers. But if you need a cash flow diagram, that information will be on the cash flow diagram when we get there. So, i.e., the effective interest rate is equal to 1 plus R, the nominal interest rate, over the number of compounding periods, all in brackets, to the power of M, which is the number of compounding periods, 1. That formula in the textbook, and it's in the end of at the end, back cover, and it's a part of your, call it your formula list, for lack of a better term, right now. So this will be available. You do not have to memorize formulas. They're given to you to begin with. So let's fill that out and determine what is the effective interest rate. Well, it's going to be equal to 1 plus R. R is 4%. That's the nominal rate right here. So 0.04 over the number of compounding periods. And it's quarterly, so it's happening 4 times a year, every 3 months. Some people get that a little mixed up, so don't focus on that when you're dealing with this. Don't put a 3 here. Quarterly means it happens 4 times a year, which is every 3 months. But I've seen some students put a 3 in there, thinking, well, it happens every 3 months, but it's quarterly. So that's in brackets. The number of compounding periods is the same. M is here, M is here. 4 minus 1. If we do that arithmetic, you should end up with 0.04060401. You can never carry too many decimals when you're calculating an interest rate, decimal places when you're calculating an interest rate, when that is not your final result. If it's going to be used later in computations, please carry it out to at least 5, 6, 7 decimal places, okay? Otherwise, you're truncating earlier than you need to, and you'll get wrong answers because it adds up. Effectively, this, if you were to terminate and say, well, let's just call that 0.04, therefore 4% is the answer, and I'm going to work the rest of the problem, but then you're ignoring this component which contributes to your answer. So everybody or students often ask me, how many should I carry? Well, what I carry is whatever's showing on the display of my calculator is what I carry. So about 9 digits is what I often carry. But at the very least, try to carry 6, 7 or more at the very least, okay? Now, one way around that is you can write it out, but to make sure you don't have a key entry error, you can just put it into a memory cell in your computer and call it forward when you need it, is a way of handling that, if you're comfortable doing that. Okay, so what do I have here? P now, which is what we're looking for, is actually equal to the future value onto 1 over 1 plus I to the power of N and N, number of compounding periods. So that will be equal to here, the future value. Remember, we've been given the future value, it's $50,000, onto 1 over 1 plus 0.04060401 to the power of N. So we're working this at quarters. No, sorry, my mistake there. This is an effective interest rate. So it is yearly. The effective interest rate, it can be different, and we'll explore that later. But for now, effective interest rate is yearly. So how many times, how many compounding periods are there? Well, there would be I have to look at the question here. 5. I guess I can leave that there. So if I do that arithmetic, I'm sorry, I don't have a 5 up here. My mistake. If I do that arithmetic, you should end up with 40. Confirmation, you should get that. That's correct. At the end, that was there's no N at the end, and I should have seen that. You're correct. Thank you for pointing that out. The slide deck that I'm using is the slide deck, and it's not in front of me now. I don't use it when I lecture this way. It's the slide deck that shows up in the asymmetric lectures. As I use the slide deck in the asymmetric lectures, and I then use VoiceOver to explain what's on there. The actual slide deck contains more point form information, and it's the VoiceOver that speaks to all of that. So you're better to, when you're looking at these videos that are posted online, you should be looking at the asymmetric lectures. There's 4 of them for this chapter, and they're in sequence. So you should be doing that, and the slides you need to refer to are in that video, if you will.
Wait, so I'm confused. You have PDFs uploaded somewhere, or you just
No,
just
not-
watch the videos?
No, if you go into the, what would you call it, into the learn content and into the particular module, chapter 2, in there will be a link to the media site presentation, which contains the video, which contains the slide deck as well as the voiceover, so that I'm speaking to the information on those slides.
It just takes me to the video. I don't see a slide deck, but I
Well,
kind
no,
of
but
want to make
have
my
you
own
opened up?
annotation.
Have you opened
stuff
up
on
the video?
side. Yeah, I have.
And you're not seeing a slide deck.
No, just the video.
But in the video, there's no slide deck?
Well, I mean, you're presenting a slideshow, yes. But
Yeah, that's what I'm saying. Yeah.
I want to make my own annotations and notes. So I was just wondering if you'd be able to convert it into a PDF to make things easier, or not. That's up to you.
Yeah, I'll think about that if you give me the moment on it.
Sure.
Okay, thanks. So we have this. I apologize for that. There's no N in this formula. The N is down here. So this formula here that we use is the same formula we had before, where we said F is equal to P to be multiplied by 1 plus I to the power of N. But now it's just a little bit of algebra or reconfiguring that formula. Excuse me. Next question. You guys really like this private channel, don't you? That's okay, though. Let's do this problem one more time. Okay, we'll say alternatively. I'll answer the last chat that came into me here this way. Alternatively, let's calculate IS instead of IE. Or maybe more correctly spoken, let's calculate I subscript S instead of I subscript E. When I refer to it often, I just simply say IS, meaning I subscript S, and IE, meaning I subscript E, just so I'm not confusing people. But in that case, it's R over M is the other formula. And in this case, it's, and again, I could do it this way. It's going to be 4% over M, which is quarterly 4, which means it is, and I guess I could write it this way, 0.04 over 4 equal to 0.01, which is equal to 1% quarterly. So now that I have that, I can go back, and that number looks a little more friendly than this one here in this case, but let's just see where it takes us. If we do it this way, we should use the same formula. Nothing has changed there. We want to know the present value. If we know the future value, multiplied by 1 over 1 plus I to the power of n, putting in number into bracket, putting in numbers here, where future value is 50,000 onto 1 over 1 plus I is 1%, 0.01, to the number of compounding periods. Now, what are the number of compounding periods in this case, though? A couple of 20s will come back to me, so I'm good with that. So we're going to put a 20 in here, and then we're going to calculate that out, and hopefully you will get what I got when I worked the problem. Same number. Now, sometimes it's not quite the same number. Nevertheless, for all practical reasons, it's the same number. So you could work your problem either with IS or IE and end up at the correct result. However, depending upon what else is in the question, one or the other will be better. Not wrong, just simply a little more direct for an answer. Otherwise, you go in what I call a circuitous route, kind of a roundabout way of getting there. Now, as to how to know at the beginning, I will point that out as we move along with other questions that are a little more involved. But basically, you're going to be looking at other information in the question. For example, if you pay a monthly bill, you might be better off with an IS monthly, because it's going to be compatible with that number of paying your smartphone bill every month of whatever it is, 50 bucks, 70 bucks. But if it's per month, then if you can convert your nominal interest rate to a quarterly, or to a monthly, my mistake there, to a monthly, it will add up with your numbers much more effectively. You could still do it with the effective interest rate, but then you are going to have to convert your monthly payments for your smartphone to yearly payments, so it's compatible at the IE level. And you just can't do that by multiplying it by 12, because then you are ignoring interest over those 12 months. So the challenge is that it becomes, when we get into more challenging questions, you will find that there'll be a better way to do it, but both ways will get you to the right answer. But you've got to make sure your data in your work is compatible. In other words, you can't mix feet and meters and get the right result. So keep that in mind, please. So that's what we have there for 2.5. Let's take a look at let's take a look at 2.6 maybe. $2.6. Okay, in this case here, Greg wants to have $50,000. Sounds familiar, eh? In 5 years, he has $20,000 today. The bank is offering 5-year mutual fund investments, paying interest compounded quarterly. What is the minimal nominal interest rate he would have to receive to reach his goal? So it sounds to me like we're trying to solve for an I value. But it's not just any, they want to know the minimal nominal interest rate. So perhaps the best way to go here is to solve for IS first and then convert the IS to nominal. So essentially we're doing in this question the reverse of what we've done in the previous question that we've dealt with. So we can use this same formula. Future value will be equal to the present value onto 1 plus I to the number of raised to the power of the number of compounding periods. But we don't know what it is, and we will work it to the IS level. It's going to be paid quarterly. So again, it's compounded quarterly. So we're going to work it at the sub-period interest rate so much X per quarter, or X quarterly as the interest rate. Once we've done that, we can then convert that number to the nominal interest rate for question 2.6. So let's put some numbers in here. We know that Greg wants to have $50,000, so that would be a future value. That's down the road a ways. We know he starts out at $20,000 today to invest it, so that's your present value. And we know that N, well, I'll finish the formula here, 1 plus I, and I'll put an S in here, to the power of what? Can you tell me how many compounding periods are there if we're going to work it at the quarterly level? I have a 20. Any more? Another 20. Any more numbers? Okay, I'll go with that. 20. Because there's 4 in a year, 4 quarters in a year. So I could write that out here, I guess, just for you, so you know what I'm doing here. But N would be equal to 4 a year times the number of years, which is 5. Is that what we have here? Equal to 20. That's where the 20 comes from. 4 times a year times 5 years gives us 20. Because it's got to be, it's being done quarterly, every 3 months, if you will. It's interest is being added to the previous amount. So if we solve for this, a little bit of algebra going on here now, I'll draw it out a little bit in a sense of how I go about this, because solving for I often means a little maneuvering or manipulation, or a little bit of algebra, maybe is a better way to put it. So we know here that 1 plus is to the power of 20 will be equal to 50,000 divided by 20,000. And save some number writing in the future, we could say, well, that's the same as 2.5. Perfect. So we could say this, if we multiply each side and take, or sorry, if we take the 20th root of both sides of this, that gets rid of this little problem here, because our unknown is inside of brackets raised to a power. So what I'm going to do here is simply say I'm going to take the 20th root of both sides of this equation. If I do that, I'm going to end up here with 1 plus is will be equal to 2.5. And I tend to raise mine to the power of 1/20th. I tend to use the this approach when taking a root. You could put a root sign over that with a little 20th on it over here. I don't tend to work that way, but you're welcome to do it if you're more comfortable doing it that way. I might even put that in brackets here. I'm going to put a line through it afterwards though. So this could be the same as writing this. If you wanted to express it that way, and there's nothing wrong with that. Mathematically, that is correct. But I'm going to work with this one here. So just to make it so I don't leave anything on the table here that's confusing, I'm going to stroke that out, but you can leave it or stroke it out or not put it down there to begin with. So what we have here then is will actually be equal to 2.5 raised to the power of 1/20th minus 1, which is equal to 4.69%. But that's a nominal rate, excuse me, that is a subperiod rate, and we want the nominal rate. So we know that the nominal rate is going to be determined from I subscript S R over M. And therefore we're looking for R. I'll do it this way to save some space here. That will go to R is going to be equal to IS M, which will be equal to 4.69, the subperiod interest rate, multiplied by the number of compounding periods, and there's 4 of them in the year. So the nominal interest rate for this question would be 18.75%. Hopefully you come to the same conclusion in your algebra/arithmetic. You should learn how to do that on your calculator. I'm not sure which calculator you're using. Probably many of you were bought from your first year math, the Casio, what is it here? I think that's the one they still use there, the FX 991MS is probably the one that you're using, if I recall correctly. Yeah, Casio FX 991MS. So if you do that, you will be, you should learn how to solve for or take the root of something this way. There may be other ways that you can work your way around it, but do know how to solve for this situation using your calculator, so you're not learning it in the middle of a question that's on an exam paper. Okay, for my next take a look at 2A as our next one. These questions that I'm doing are the same layout that was in the asymmetric lectures that I gave in that's online. So as you go through those videos, you will see on the slide, as well as in my voiceover to the slides, you will see reference to questions, EOC questions, and supplementary questions. This is a supplementary. So let's take a look at that one. Already did this one. How come? 2A. Sorry, 2D I want to do. My mistake. 2D as in David. (2D), in case you don't have your books in front of you, or you haven't printed these off yet, or have them on a file in your computer, you should be able to offload that easily. But the effective interest rate is 8% annual. What is the effective interest rate over 3 years? So what we're doing here, and we have already talked about interest rates a little bit, about they're usually quoted at an annual basis, the effective interest rate annually. But it can be a different number, and that will prove useful in solving some of the problems at a later time in this course. Not so much in this chapter, but as we get into chapters 3 and 4 and 5. So what they're saying here is, what would be the effective interest rate there? Hint, in this question, we are moving from one effective interest rate to another effective interest rate. You must treat the effective interest rate of 8% then as a sub-period interest rate in the formulas. So if you're doing that, it's a bit of a maneuver, but it's very legitimate and it works. So what we're saying here is our formula for this, in using that question, will be, once again, we're going to go to our basic formula. We have an effective interest rate. It's going to be equal to 1 plus the sub-period interest rate, which is R over M, but that doesn't come into play this time, to the power of M minus 1. That's the formula. Again, that is, i.e., there's two versions of that formula. One where R over M is substituted for this number right here, or this notation right here. Both of them are in the formula sheets, the back of book, also published in Learn. So we want to know if this is per year, is what we've been given. What would it be for 3 years? And we do that by treating the 1 year as a sub-period interest rate. So IE will be equal to 1 plus IS, and we said that this was 8%, so 0.08 to the power of, how many years did we say? 3. 3 years minus 1. So this here will be part A. I guess there's an A and a B in this question, so I'm going to label them and keep them separate. This would tell us here then that IE is what we're looking for, but it's the effective interest rate for 3 years, not 1 year. I'm writing this up here. Sorry, but that's all I'm doing here. 0.08 power of 3 minus 1. And that will be equal to, if you work it out, at 25.9712%. In this question, we started out with 8%. I want to write this up here. It's 8% compounded annually. It tells you that is the IE that we're beginning with, but it's compounded annually. So what that means to us is that if you were paying 8% annually as an effective interest rate, treating it as a sub-period interest rate, but you want to know what is the equivalent of that if it were for 3 years. So you've kind of got to add them together. And you just simply can't multiply by 3 and get the answer. You're eliminating the compounding interest effect by doing that. So 8% annually is the same as 25.9712 every 3 years. These two numbers are the same, but you could see here, and some people tend to do this, they'll say percent every year must be, and I want to know what is it for 3 years, it must be 3 times 8, 24. Well, that would be wrong, because the correct answer is 25.9712%. Because again, you're ignoring interest if you just simply do that direct multiplication. You have to work it through this formula here. We'll do part B here. Very similar. IE 1 plus IS to the power of M minus 1. Let's put some numbers in here.
Can you raise your piece of paper a little bit?
Yes, I sure can. Thank you so very much for pointing that out. Maybe I'll do it this way. There we go. Just focus. Okay. Where am I here? It's going to be IE is going to be equal to 1 plus 0.08. And again, all we've done there is take the effective interest rate for 1 year and call it a sub-period working towards 3 years. Part B, 4 years for part B. So it would be to the power of 4 minus 1 equal to 36.048896. How could I word that? Every maybe. Per 4 years. So again, if it's 8% back here, and we're looking at 4%, we just can't multiply that by 4 to get it for 4 years. That would be 32. 4 times 8, 32. But instead, the actual answer is 36.048896. And that's because, again, I know I'm repeating myself, is that if we just simply do the straight multiplication, we're ignoring the compounding effect of interest over that 4 years. So we can use this formula here, and this is pointed out in the textbook. We can use this formula here as a way of, excuse me, use this formula here as a way of changing the effective interest rate from, say, 1 year to more years, 2 years, 5 years, 20 years. you use this formula here, where you're starting out with an IS of whatever it is, in this case 8%, and you're going to convert it, if it were for, what would that 8% per year be equal to something per 20 years? So M would be 20. Solve the arithmetic and you get an answer. So that'll give you that insight there. Okay. It's what time we got? It's 3 to 11, so we're done. We'll pick this up and do some more in chapter 2 next week. We will probably conclude that next. When I say next week, I got to think about that, don't I? Because I really mean in 2 weeks. Next week, nobody's here. If you're working at these problems over the holidays, and if I have the time, because I will be working, I don't get the break like you do. But if you send me questions like, I can't solve this one, this is what I've done so far, I'm stuck, I'll try to take a quick look at it and give you some resolution of that. Try to make sure your work is clear for me to follow, though, not all over the page. I knew a couple of years ago one person who seemed to, for one reason or another in this class, always wanted to work from the bottom of the page to the top of the page. And until I figured out what he was doing, which didn't take that long, it was a little bit confusing for me to get my head around the work he was presenting me with. So don't do something like that, and don't lay your work out in circles or in sinusoidal patterns or something like that. Top to bottom works really well. Make sure your numbers are clear, your letters are clear, and that's very helpful for me in following through what you're doing. So I'll leave that with you. If you have any questions, what I typically do when I sign off is simply to let you do all the sign off. When there's only a couple of people left, I'll sign off, but maybe someone wants to hang around and ask me a question, which I could try to handle at that time. So right now I'll stop sharing and I'll go to my, and I'll stop recording here as well. And if you want to hang in here, fine.